In this video, we're going to look at concentric, eccentric, and isometric muscle actions and how you tell the difference. You know from your readings that a concentric muscle action is when you have a muscle that's actively contracting and it is actually shortening as it contracts. In an eccentric muscle action, you know you have a muscle that is actively contracting, but it's actually lengthening as it's trying to contract. That is, the external torque is winning over the internal torque that the muscle is producing. In an isometric muscle action, a muscle is actively contracting, but it doesn't actually shorten. It stays the same length. In that case, the external torque and the internal torque are equal so that there's no movement. So let's apply this and see how we actually determine whether any given muscle contraction or contraction of a muscle group is concentric, eccentric, or isometric. In my hand, I have a 4-pound weight, and I'm going to take that 4-pound weight and I'm just going to bring it up to my shoulder, just like that. Okay? So the first thing we have to do is determine what muscle group did that. In this case, it's the elbow flexor muscle group. The elbow flexor group brought the weight from down here up to here. And while it was doing that, that elbow flexor muscle group was shortening as the elbow was flexing. So that's an example of a concentric muscle contraction. Now let's take it just the other way. I have my 4-pound weight up by my shoulder, and I'm going to lower it slowly down. What's causing that weight to go down? Is it the elbow extensors? No, it's not the elbow extensors. What's causing the weight to go down is simply gravity. So then you have to ask, what's controlling that motion? What muscle group is controlling that motion? From here, lowering it slowly down to here. What muscle group controls that? Well, it's the elbow flexor muscle group that resists gravity and lowers the weight in a controlled manner versus just letting it flap, letting it go totally to the pull of gravity. So, if it's the elbow flexor group that is controlling this motion, that's the group that's active, that's the group that's contracting. What is that elbow flexor group doing as the weight lowers? Is it getting shorter? Is it getting longer? Or is it staying the same? Well, it's getting longer. Thus, from here down to here is an eccentric contraction of the elbow flexor group. Okay? I'm going to put the weight down, or in my left hand, a minute. And I'm just going to come over to the little tray on the whiteboard here. Now here, I have a little tray, an immovable object, all right? And again, with my right hand, I'm going to get under this immovable object, and I'm going to try to pull it up. I'm going to try really hard to pull this up. Hopefully it'll stay on the wall, okay? Now, what muscle group is doing this work of trying to pull this up? Well, it's the elbow flexor muscle group that's trying to flex my elbow and trying to pull this tray up. But I can't make that tray move. All right? It's too strong, it's immobile. So that elbow flexor group, is it lengthening, shortening, or staying the same length? Well, it's staying the same length. Thus, this would be an isometric contraction of the elbow flexor group. Let's look at the elbow extensor group and some examples with that. So, I have my same 4-pound weight. I'm going to start this time with this weight up over my head. Okay? And I'm going to slowly lower it back like this. Okay? I'm going to start here and slowly lower it like this. So this is the movement that I'm looking at. Okay? As I slowly lower it, my elbow is flexing. Does that mean this is a concentric contraction of my elbow flexors? Not at all. It's gravity that's pulling the weight down. The elbow flexors really aren't participating or active at all. The muscle group that is controlling this motion from up here, slowly lowering it down, what muscle group is controlling that? What muscle group is active? Well, it's the elbow extensors that are controlling that slow lowering of the weight from a fully extended position down to an elbow flexed position. So it's the elbow extensors that are active. Now, are those elbow extensors getting longer, getting shorter, or staying the same length? Well, from up here to down here, those elbow extensors are actually getting longer. Thus, this would be a eccentric contraction of the elbow extensors. Okay? Now, from here, let's try and strip my elbow up. So now I'm going to lift this weight up against gravity. Okay? What muscle group just did that? Starting here, ending there. What muscle group did that? Well, those would be my elbow extensors again, straightening or extending my elbow to lift this weight against the resistance of gravity. Did those elbows extensors get longer, shorter, or stay the same length? In this case, they got shorter. So that would be a concentric contraction of the elbow extensors. Now I'm going to take this weight and put it down by my side again, and with my right hand that we're working with, I'm going to push down this time, push down against this blackboard tray. And I'm going to try to push that tray all the way down to the floor. But because it's immobile, I'm not going to make any progress. So what muscle group in my right arm is actively pushing down against this tray? It's my elbow extensors. So are my elbow extensors getting longer, shorter, or staying the same length? Well, they're staying the same length. There's no movement present, so they're staying the same length. Thus, that's an isometric contraction of my elbow extensors. So, just to review, anytime you're looking at a motion and you're trying to decide, is this a concentric, eccentric, or isometric contraction, you need to do two things. The first thing you need to do is decide what muscle or what group of muscles is actively controlling that movement. The second thing you need to decide is, now that you've chosen your muscle group that's actively controlling that movement, is that muscle group or that muscle getting longer, getting shorter, or staying the same length?